What if the future of computing isn't on Earth at all? What if the next generation of data centers is orbiting our planet right now? Space-based computing is no longer science fiction. It's already happening.
The way to think of AI in space is that in order to achieve any meaningful percentage of a Kardashev 2 scale civilization, where you're using even a millionth of the sun's energy, you must have solar-powered AI satellites in deep space.
Modern data centers consume enormous amounts of energy, not just for computing, but for cooling. Servers generate massive heat. Cooling systems require huge quantities of water. Power demand is exploding due to AI workloads. Companies like Amazon, Google, and Microsoft are now seriously considering building their own nuclear plants to keep up. Even then, electric grids are reaching their limits, and fresh water is becoming far too valuable to waste on cooling data centers. So, the question is obvious. Is there a better place for compute-intensive infrastructure? Space offers two things Earth is running out of: near-perfect cooling, unlimited solar energy. In orbit, heat can be radiated directly into deep space. No atmosphere means no traditional cooling systems. Solar panels receive constant, uninterrupted sunlight. And there's another benefit: lower CO2 emissions, since fewer terrestrial power plants are needed. This is where space-based data centers enter the picture. Recently, SpaceX launched a Starcloud test satellite on board a Falcon 9 rocket. Here, what makes it remarkable: around 60 kilograms in mass, equipped with an NVIDIA H100 GPU, designed to test space-based AI computing, running a version of Gemini, focused on antenna testing and data transmission. This is not a concept demo. This is real hardware running real workloads in orbit. And it's only the beginning. The next Starcloud satellite is planned for October 2026. As promising as it sounds, space data centers face serious challenges. Cosmic radiation can flip bytes, damage memory, kill storage devices. In fact, NASA has already tested SSDs on the International Space Station. The result? 9 out of 20 SSDs failed. The cause? Cosmic radiation. That's a major reliability issue. Yes, space is cold, but cooling is not trivial. You can't use air or water. Heat must be emitted via infrared radiation. Poor thermal design can trap heat instead of removing it. Managing heat in a vacuum is a physics problem, not an HVAC problem. On Earth, a failed SSD is a minor issue. In orbit, it's a nightmare. Imagine this: a satellite in sun-synchronous orbit, one critical component fails, no technician, no easy repair, no quick replacement. Maintenance is currently the single biggest obstacle to scalable space data centers. Space computing isn't limited to Earth's orbit. With Intuitive Machines' IM-2 Athena mission, a data center experiment was sent to the Moon. This opens the door to lunar compute nodes, deep space data processing, reduced latency for space missions. Processing data where it's generated could become a major advantage.
Now, I read just days ago about a Google project called Suncatcher would actually use satellites in orbit to create and harness some of this energy. I had to frankly Google it to see if it was a real story or whether I was being punked. Tell us about this technology.
In that spirit, one of our moonshots is to how do we one day have data centers in space so that we can better harness the energy from the sun, that is 100 trillion times more energy than what we produce in all of Earth today. So we want to put these data centers in space, closer to the sun, and I think we are taking our first step in 27.
Even Earth-based infrastructure is starting to borrow ideas from space. Google's project Suncatcher explores advanced solar collection and new ways to route energy more efficiently, pushing power generation beyond the limits of today's data center design. The line between space infrastructure and Earth infrastructure is already beginning to blur. Space-based data centers won't replace Earth-based ones overnight, but for AI training, high-density compute, space applications, energy-constrained regions, they may become essential. We are watching the birth of a new computing layer, not in the cloud, but above it. If you found this interesting, hit like, subscribe, and let me know.